So this is the time we're going to do algebra, right? Plug in numbers and calculate numbers. So we're going to evaluate limit using properties of limits, develop and use strategy for finding limits. They're giving you strategies. Evaluate limit using the dividing out technique. And this is a factor, that's what they're talking about, okay? And then evaluate limit using the rationalizing technique. Evaluating a limit using a squeeze theorem. So we got different ways to evaluate limits. I will just cover 2, maybe 3 today, and I will cover rest of them tomorrow. So properties of a limit. If you have a function is a constant, it does not matter what number you plug it in, that be all constant. I'll give you an example in a minute, okay? It's a continuous function, it's a basic limit. And if limit x, which is a continuous function, right? Straight line, diagonal line. In that case, whatever number you plug it in, that's your number as your limit. Next one. Again, it's a polynomial. So that you just simply plug it in. So basically, this is just telling you, if your function is continuous, you simply plug it in and evaluate. Is everybody with me? So in other words, y value is same as what? Your limit. So limit and y value are same when function is continuous. Is everybody with me? All right. Look at this one. Let's graph this one so you know this is continuous function. It means y equal to what? 3. So simply what? Draw a line. That's my graph. This is what the graph looks like. Is everybody with me? Or I can say f of x equal to 3. That's what that means.
Y equals 3.
This 3 right now really means what? F of x equal to 3. So it doesn't matter what x you give you, it's always 3. Did you see this graph? Any number that I give you, that's always what? 3. So it doesn't matter. X goes to 2. What's my limit? 3. What about the limit? X approaches negative 100 of 3. What's my limit? Still what? 3. Because it's a constant function. It's a straight line. So my limit is always what? 3. Because f of x equal to 3 means it doesn't matter what x I plug it in, it's always 3 because it's a constant function. It's called constant function. Is everybody with me? F of x is my function. My function is f of x equal to what? X. So what's my graph looks like? Oops. That's what my graph looks like, right? So, what's my limit? I simply plug it in because this is a continuous function. So I can think of this as f of negative 4, so which means what? F of x equal to x. So f of negative 4 means what? Simply negative 4. If I change my limit, then what's my other one? So tell me about this then. What's my limit? Simply 10. Is everybody with me? So what am I doing? I'm simply what? Evaluating. If it's a continuous function, you just plug in the number. X equal to negative 4, so I'm plugging negative 4. In this case, I'm doing a what? Plug in x as a what? 10. That's why I have a 10. Does it make sense to you, class? All right, next one. X squared. That's still what? Looks like to me a continuous function. It's a parabola. function. Yeah, it's definitely a continuous function. So x squared. So what am I doing? This really means same as what? F of x equal to x squared. So I'm looking for f of which number? 2, which is 2 squared. X equal to 4. Can you find me another limit? X approach to -4. What is my limit? This is the same as what? -4 square that, which is what? 16. Does it make sense to you, class?
Yes.
Is everybody following me? Okay, great. All right, there's another one. More properties. So, B and C, the real numbers, you know what real numbers are? Like counting numbers, negative numbers, they're all real numbers. Fractions, they're all real numbers. Okay, and let n be a positive integers, and f and g be a functions with a limit. So this function has a limit called L. And this function called limit has what? K. Then guess what I can do? I can multiply by a number. The b can be like 3, 5, or 10, any number. So I can just simply multiply them, I get a what? The number plus my limit. For example, say b is equal to 2, L equal to 10, what's BL then? 20. That's what I can do. So limit, you can just multiply by constant. Look at another thing you can do. You can do what? You can add to limit or what? You can subtract limit. So you're doing just like a number, regular numbers. Look at what you can do also. I can multiply limits, and I can divide limits, but you cannot do which one? The k cannot do which number? 0, because I cannot have a 0 in where? Denominator. And can I also do the raising power? Yes. So you can do all this. You can do add, subtract, multiply, divide, raising power. You can do all of that with a limit. For example, right here. What is my limit for this? First thing first, this is a continuous function. Yes, this is continuous function. So I can simply do what? Plug it in, right? So this means 4 times 2 to the what? Square plus 3. 4 times 4 plus 3, which is what? Yeah. That's my limit. See, I just did what? I add to limit. This has a limit, that has a limit. I add them together to make a 19. Does it make sense to you, class? You can add limits. You can subtract limits. Our next one. Oh, this is the same thing. Do you remember this? Okay, this property right here is the one that we did very first lesson. Okay, so if P is a polynomial function and C is a real number, then P of X is the same as P of C. And I will show you what this means, okay? So if R is a rational function given Rx equal to P of X equal to Q of X, I have two functions. I'll explain to you in a minute. Let's just read for now. And C is a real number such that Q of C is not equal to 0, then I can write it as this. So in other words, I have this function right here. So you have two functions, P of C, P of X, and Q of X. So let's check. If I plug in 1 in the denominator, does it become a 0?
No.
No. That means I can simply what? Plug in the number. Because whenever you have a denominator, you have to worry about whether denominator become a what? 0. Since this, you gotta always check. Your denominator is x plus 1. So let's plug it in. Okay, your denominator. So f of 1, I want to know what that equal to. 2. So I'm safe, right?
Yeah.
It's not a 0, so I'm okay. So I can simply plug it in here then. So I will simply plug it in. So I will do 1 squared plus 1 plus 2, everything divided by what? 1 plus 1.
Okay.
So that gives me what? 4 over 2, which is 2. This is what they're talking about. If you have a rational function, and your denominator is not a 0, you can simply what? Plug in your number. But check this though, okay? Just think about this example of this. Let me give you other example. Say same number. I want to do exactly the same thing, but if I plug in this,
It's going to become 0.
can I do this one?
No.
Just simply plug it in.
No, because that's going to be 0.
Because that's right, let's check. My denominator is f of x equal to what? X plus 1. If I plug it in, negative 1,
It's 0.
I get a 0. So it's undefined. I cannot do that, right? You get undefined here. So in that case, I got to do a different way. That's what I'm going to show you next. Is everybody with me?
Yes.
All right, next one. Limit of a composite function. Composite means I have a one function and I have another function. So this is what it happened. When you evaluate this function, you get an L. You get an L as your what? Limit. Now I'm going to use this L as my x value. And I'm going to evaluate that, and I get a different number. So I will show you. This is a composite means. This is what that means. Simply, this picture is what composite picture. You have x, you have a g, you have f of x. All right? So I have an x number here, like 1, 2, 3, whatever. And f g of x, say I have g of x equal to, say I'm going to call g of x equal to x. Then if I plug in 1, I get a 1. 2 gets what? 2. So how about to the square? So a different number. 4 and 3 gets what? 9. Is everybody with me? So now I have another function called f of x. I'm calling this is equal to, say, square root of x. All right, so what happened then? If you plug in 1, what do you get? 1. Plug in 4, what do you get? 2. Plug in 3, what do you get? 3. So, look at this one, class. This is my domain. This is my what? My range, right? So this is my domain. This is my range. Now, this range become a what? Domain. This is a domain to which one? That range. Are you with me, class? That's what's called composite. I'm composing what? 3 different things to make one. It's like you are composing and you are moving things together. This is a domain of my x is my domain. This is supposed to be my range. So now range become a what? Domain of which one? Other one. Yeah, that's one. That's what's called. Find the limit. All right, let's make sure. By the way, can I have a negative number in the square root? No. So I just need to make sure this is a non-negative. So if I plug in 0, does it get a non-negative?
Yes.
That means I can simply what? Evaluate. So I just plug this my number in. Which gives me 2. All right. Next one. Let's do the problem here. So cube. Okay, cube root doesn't matter. Cube root you can have negative numbers or positive numbers, doesn't matter. It was the even number root.
Yes.
Even number root you cannot have a negative. It has to be 0 or positive number. So in this case I don't even have to check. I can simply plug it in. So what do you have here? Cubic root of 2 times 3 squared minus 10. 2 times 9 minus 10. Cubic root of 18 minus 10. Okay. I cannot add and subtract. I gotta work on this. 8. So cubic root of 8 is same as what? 2. So that's my limit.
That's good.
So limit is here is 2. Limit here is 2.